Hello, I am Andrea Bernardes and I'm here to present some results of our project, the Sb-RECMEMTEC. So, our consortium is organized by 4 universities, two from Brazil, one from Spain, one from Chile, and one company from Chile. And the group has already experience in working together. We participated in 2 CTED projects and in different Hispano-Brazilian programs of inter-university cooperation. So when we build the consortium, we build based on our previous experience in working together. About the budget, we can see in this table that the total allocated budget is a little bit different to each group, but all universities have received some national financing, and also they present their own financial money. The company Transducto participate in this consortium just with own financing. So the project is supported by RMI and funding agencies of each country. And as a function of the different national funding organizations' internal process, the groups have different project start and end dates and different times and roles. So especially for Brazil, we began with the project in the middle of the lockdown and really pandemic situation. It was a challenge, but we think that we were able to manage it because we always share clear information and objectives, so between the enterprise and the universities. We have done different online meetings and we are always in touch by WhatsApp and so on. About the problem definition, it's related to the copper industry. Copper is a metal widely used for or in alloys in different types of industry, and it's found in nature mainly in the form of sulfide minerals and oxides. In Chile, most of the copper is obtained from sulfide minerals, but several purification steps are carried out to obtain a high purity copper product. So several purification steps mean several different wastes that are generated during the process. When we associate this waste to the risk of a depletion crisis for some metals, there are some efforts to increase the extraction of these metals also from the copper industry or from the copper mineral. And among these metals, antimony and bismuth have been considered because they are critical metals. In the coming years, the mining industry will face a challenging situation, or more challenging than today, because of the reduction of the purity of mineral resources, of the increased global demand for copper, and increased environmental policies. So it's important to think about the wastes that are being generated and about extracting other metals from the same mineral. Talking about the state of the art, copper sulfide minerals are processed by pyrometallurgical processes. So there is a mineral processing step, a mineral concentration step, a concentrate casting, and at the end an electro-refining to obtain a copper cathode with 4.9 of purity. This electro-refining is carried out in an electrolysis cell, and sulfuric acid is used as electrolyte. This sulfuric acid must be purified to be reused. One of the impurities that are removed during this purification step by an ion exchange is antimony. And during the ion exchange regeneration with chloride acid, it's generated a solution containing antimony or a wastewater. Then, one thing that is important is to understand in each of these steps where we can find other metals or antimony to be recovered. So we have done a study about the chemical composition of the main stains of copper production, and the results shows that there is antimony in many of the wastes that are generated during the process. But the highest antimony content is in this solution of the ion exchange regeneration. So at this project we are studying this, mainly this solution, but other projects can be then organized to study the recovery of antimony from other wastes. No? So the key objective is the regeneration of antimony by electro-electrodialysis. And electrodialysis is a membrane separation process where ionic species are selectively transported through ion exchange membrane. So when we talk about electro-electrodialysis, we are using the same principle, but at this process then we are going to recover antimony not only in a concentrated solution, but mainly as a deposit on the cathodes, meaning it is a process used for antimony electrowinning. About our work structure, we have distributed tasks among the different groups and countries to achieve the main result. That's going to be the definition of operation parameters and an efficient technological and economic efficiency evaluation. I'm going to talk now a little bit about the experiments and results that were done in lab scale with synthetic solutions. These solutions were produced in the laboratory as a surrogate in terms of chloride acid and antimony of this wastewater that is generated on the ion exchange regeneration at industry. So Brazil and Spain have worked with this produced solution, and the idea is to recover antimony. We have to consider that when we have a solution containing acid, chloride acid and antimony, there are the possibility of different chemical reactions forming from anions to cations of antimony. And what is important, or important parameter when we think about ion exchange membranes. And there is also the possibility of different electrochemical reactions. The one that is more important for us is this cathodic reaction, where we obtain the antimony as a metal deposit on the cathode. But we should consider that in the anodic part of the cell, there will be the possibility of reoxidation of this produced antimony. So the membrane, the idea of using membrane is to separate cathodic to anodic reactions and then to have this reaction occurring and recovering antimony. So in Brazil we start working with lab scale experiments, and we have done the antimony electrowinning in a single compartment cell, and also electrowinning with two compartments, and the compartments were separated by a cationic membrane. The idea then to avoid the reoxidation of antimony. We have obtained different qualities of antimony deposit, and but it was possible to recover antimony from the solution. We are also studying electrodialysis process in order to recover the acid to be reused on the ion exchange regeneration. In Spain, they have studied the electrochemical parameters to the recovery of antimony by electrowinning. And it's possible to see that no deposits are formed, so it's not possible to see any deposit, antimony deposit, on the copper cathode when less cathodic potentials are used. The most important potential is this one, where we have this reaction occurring, so the reaction of reduction of antimony, and at this potential it was observed a good deposit with a good adherence and uniformity. When more negative potentials are used, then there is the hydrogen formation production, and this generates a more less adherent deposit. So the hydrogen generation generates a deposit that doesn't have the same quality. They have also studied in Spain the effect of hydrodynamic conditions and the effect of antimony concentration on the electrowinning rate. And it's possible to see that in a higher Reynolds number or in a higher antimony concentration, there will be a higher electrowinning rate, a faster one. And this is related to a better mass transfer in the cell. Here there is a video where we can see the deposit occurring on a copper cathode. So from the beginning we see the antimony being reducted and deposit. This is a solution with chloride acid and antimony. So I will go a little bit faster just to show you the end of the process. That's it. Here we have our antimony. Other experiments that were carried out were experiments with real solutions. So the solutions that were generated on the company, on the copper production industry. So these experiments with real solutions were carried out in a pilot plant in Chile, and the experiments were carried out by the University of Chile and by Transducto, the company that is associated with us in the consortium. They developed this technology, DOMTEC, it's electrowinning processes, to treat the waste from the mining metallurgical industry. So considering that we have a copper production industry, the wastewater generated is going to pass through their process in order to recover water, copper, and in our case, antimony. So to really see if in the case of antimony it was possible, they received 10 cubic meter of electrolyte rich in antimony from the plant of Chuquicamata division of Codelco, Chile, treated it, and here are the deposits that they were able to produce. So there is also a video here. So their cell, they have membranes, and it's an horizontal cell where we can see the production of antimony. Here it's the electrode, the cathode, with the deposit. So it's also possible to see that it's not difficult to remove this antimony from the cathode. So it's going to be easy to separate the antimony metal from the copper cathode, or from the cathode. In this case, it's not copper. In order to recover the metal. Another things that we are beginning to do is the membranes preparation or production. So we have the idea to process all the steps that we have already carried out with the commercial membranes, but with membranes prepared in our groups. So the idea is we began with different formulations, so 19 membrane formulations have been prepared so far. They are being characterized, and from until now the M70 membrane is the best one that we produced because it has similar properties as the commercial membrane. In January this year, the membrane production system was purchased to produce membranes in bigger membranes, or membrane with commercial dimensions. So we intend to produce them to be tested in this pilot plant from the company in Chile. This is our idea. So future tests include this membranes preparation and the determination of barrel operational parameters with membrane, without membrane, with commercial membranes, without with our produced membrane. And we think that all these results were possible just because we have many benefits of this transnational project. First of all, there is the promotion of recycling and circular economy among the different countries that are associated to the project. But especially there is the cooperation exchange of experience and knowledge between companies and universities, and between universities with different backgrounds, what turns the results much more interesting for everybody. To discuss these results, we organized in December 2020 a workshop. It was organized by the university, an online workshop. And then in October 2021, there was another workshop that was organized by the Metallurgical Association of Chile. And also in October, another workshop that was organized by the Brazilian Association of Environmental Engineering. These three workshops are at YouTube, so it's possible to see them and see what we were discussing there. Besides the workshops, we had also published 3 different papers in international journals so far, and also one work at the meeting of the International Society of Electrochemistry. All these results are better explained at our webpage, and some results are presented also on Instagram. So, and if you want to discuss more about the subject with me, this is my email, and I can also send your questions to the other partners of the consortium. Thank you very much. Gracias. Obrigado.